So as you begin, we're going to just discuss a few modeling practices that can really save you a lot of headache down the road. So there's going to be a lot of different modeling practices. These are just going to be the ones that I've compiled to be the simplest and most straightforward and, easy to apply right off the bat. The first one is going to be apply transforms before you start modeling. So if we look here, we have two different objects. They're the same object with the same bevel modifier that's being applied, but yet they look different. This one looks correct. This one looks all weird. And essentially what's happening here is that this model, both these models are being scaled. One has applied transform, one doesn't. So if we look at the transform values over here, specifically in the scale right there, you'll see that this is going to be 1. This is going to be, a bunch of random numbers. And that's because if we zero this out, or if I just 1 this out, Blender thinks this object is this. The modeling operations can only see this object right here. But when we scale it like this, it becomes stretched. So in order to unstretch it, in order to make this the actual object, we have to go to Object, Apply, and then we can just do Scale. All transforms will just apply this to everything. And when you get into rigging and stuff like that, all transform will be important. But in this specific case, if we just did apply scale, it'll go ahead and fix that. So this can be really problematic with like UV operations, any kind of like modeling operations, modifiers especially. So next up is going to be topology. And topology is essentially just the way the flow of the geometry is. And this becomes important with subdivisions, rendering, and deformations. The first two, subdivisions, rendering, are going to be the most important. Deformation is going to become important when you get into characters, but for the basics, we're going to stick with how to apply this in terms of subdivision and rendering. So this object right here, you can see we have two different cylinders. The shape of them both looks the same. One's rendering funky than the other. So this is all like weird triangulated. This is because we're working with triangles right here. And we've got triangles here, but we're primarily working with quads. So with topology, quads are best. Triangles are okay on flat surfaces. And then only use n-gons if you really know what you're doing. Those are some 3 key things to apply in your practice right away. So this has triangles and it goes all the way up to this edge right here. So when it's being subdivided, if we actually look at the topology right here, you can see that those triangles, even though they're only right there right now, is creating some really weird geometry right there. But if we actually look over here, you can see it's much smoother. So this is where topology comes in. So we'll talk about this a lot as we go. You're not expected to be a master of it, just with this one chapter. It takes a lot of practice and a lot of trial and error to really nail this stuff down. But long story short here, if we were to take these triangles and then only make them triangles where it's a flat surface, we'll see that the topology becomes fixed. We no longer have those things. And if we actually subdivide this a couple times more, it gets even smoother like that. So we'll talk about this a lot as we go. Again, it's something that takes practice. To wrap it up, quads are best, triangles on flat surfaces, and only using n-gons if you really know what you're doing. Some general things to avoid. Again, these things sometimes cannot be avoided, and we'll have a chapter on how to fix a lot of this stuff after we go. But this is a good list of things that do come up by accident a lot of times. And this is how you can spot them. This is how you know it'll be causing a problem. And then as we go, we'll talk about how to fix it. So T vertices. So that is basically like this. Anytime you have a piece of geometry that has a vertice, that looks like this. And this is essentially a good sign of, an unnecessary n-gon. So this one right here actually has 1, 2, plus 3 different sides. It looks okay here. But if you're trying to do any like edge loops or anything like that, if I were to apply insert edge loop right here, it doesn't know what to do because it has bad topology. Double-sided faces. So over here, if we check this out, so double-sided faces right here. If we check this out, we have a cube. It looks like a cube, but for some reason it has this like top right here. That's because there's actually 2 different faces on this top geometry right here. So that can be really, really problematic. So watch out for those as you go. So vert gaps generally happen whenever you have vertices that are not technically connected. They might look like they are connected and they might be sitting close to each other or on top of each other, but they're not connected. So you can see here how this bottom is rendering smooth, but these up here are actually not. There's like some weird, there's a kink in it, and that's actually because there is a gap in this vertice right there. Again, we'll get into how to fix that stuff as we go. Internal and unseen faces. So this happens whenever you have an object like this, that if you actually zoom in here, there's actually a polygon on the interior here. So this can happen accidentally. It can be really problematic. So be sure to watch out for those. Floating vertices. So this happens when we have something like this, where we just have a vertice in empty space over here. And like technically, if we were to like do something like apply an extrusion to this or something like that, it can be really problematic because then it's creating actually an edge there. And then non-manifold geometry, and then non-manifold geometry. So this is going to become important because certain UV operations, certain polygon modeling operations, they can just flat out just not work. So for example, if we over here, if we try to apply an edge loop there, you can see right off the bat, it gets really weird because it doesn't actually know where the object is. It can't actually apply a loop around this whole thing. Things like this, you know, where we have that flipped polygon, if we do an extrusion on this, it then does all sorts of weird stuff like this where, you know, it's just not going up right. So there's that. So be sure to watch out for those. Again, to wrap this up, you're not expected to be a master of this stuff. This is meant to be something that, you know, you can start to learn the basics of now, and then as you progress, refer back to this chapter frequently.